Hello, everyone. We hope you are all doing well and staying safe. We'd like to welcome you to today's webinar. Moshe Ben-Talila, who will be conducting the session, has been the manager of VisiMix's customer support for over 12 years. He has both a BSc and an MSc in chemical engineering in the field of reactors design. He was involved for more than 15 years in technological transfer as a pilot plant manager and as a product manager in an API company. In conjunction with this, he has submitted his PhD thesis about the application of practical methods for scale-up process in a specific field in the chemical process industry to show its validity to the chemical industry as a whole. He was part of the team that wrote a syllabus for a BSc degree program in pharmaceutical engineering, contributing the relevant studies for the chemical engineering profession. He is also a lecturer in reactor design and principal of fluid dynamics for the BSc degree program at the Azrieli College of Engineering in Jerusalem. In this session, we present our new product, Scaling Up Down. This new software will guide engineers through each step of scaling up-down efforts, offering exceptional expertise in processes, fluid dynamics, mixing phenomena, simulation, and mixing equipment development for all major process applications. During the webinar, please feel free to write any questions in the chat box. We will try to answer them during the session or afterwards via email. Enjoy today's session. Moshe, the microphone is yours.
Okay, thank you very much, Marty, for the introduction. And we are many people here connected, so if you have any question, please feel free to write in the chat. We'll try to answer during the meeting. I have uploaded the presentation in PDF file in your handouts, so you can review and you can take it and download. It's a pleasure for me to share it with you. So today we'll talk about something that is very important for VisiMix company, and we are working on it a long time, because the base of all these products that we developed during many years was to support our customers to transfer processes from lab to production, from site to site, or so-called now technical technology transfer. So today we are very happy to release a tool that in a product and in 1 or 2 clicks you will be able to have a very first start point with a recommended design about the scale-up parameters for processes. This is that we call new product VisiMix Scale Up and Down. And of course, remember that we need you. All of you are involved in some way in the chemical and pharmaceutical industry. So take care about yourself, because by the end, all the force of the scientific community is in some way helping to release a new vaccine or new drug that will help all the world to coming up and coming back to the position we were some months ago. So please take care of yourself. Now, we talk about the company some minutes, so people that are new, we have some motivation about why we are talking about this new release that is really a new release, that are doing some kind of summary of what we expect, speaking about it about 20 years. And of course, try to connect it with the real life. What is the product we'll talk about, and after that, I will not cover all the products we have in the company. As you can see, we have a lot of them, but you will have in your hands when you would like to contact us, or will contact you and to try to generate some configuration of products for your company. You will have it in front of you. And of course, I will open the software and show to you how the software can be operated in a very simple way, like normally in VisiMix. So VisiMix is a unique software because really it's a model. And we use a software in order to provide to you knowledge about the influence of the mixing in the process. So we have a model of mixing, and we use the solution of numerical differential equations about momentum transfer to know the velocity, and we use theories, Kolmogorov theories, Dixie-Lines and Prandtl theories, and many others, and we combine with some experimental data that we collect during many years in order to generate the model that will provide to you mixing parameters that we know can influence the process in some way. And we summarize these mixing parameters in the way that will be available for you now in a one-click button. And this is the news. All of this now will be in one-click button with explanation about why this parameter is so important for your specific application. The software is simple to use. You don't need to write any line in the code, or is ready to use. You need only to collect the data that normally you are looking for in order to calculate mixing parameters in different kind of correlations or simple tools or complicated tools and so on. Our products allow significant savings in time and cost, drastically reducing the need for trial and error, because this is the model for mixing. It was designed for mixing, for a stirred vessel for a stirred vessel, mixing in a tank connected with the process. So we are not looking for other constants that are representing some flow and put into the stirred vessel. We develop a model for the stirred vessel, and we use all the tools in order to solve the main model. This is the reason that we have accurate and good results in many uses. The model was developed in Russia by Professor Leonid Braginsky and his team. They invest a lot of time and money for it, and their job was to be sure that they're providing a good solution for the industry in Russia during the transfer technology there. Okay. I have some notification about the 1 minute, please. Okay. So they invest a lot of time and money, and their main job was to be sure that the technology transfer in Russia will run in a good way at this step. So that, of course, part of our customer support. When you have any question, we are consulting together and try to provide to you not only an answer about how to operate the software, is more how to help you in your project. So in summary of this part, VisiMix is based in physical models supported by empirical data. We solve the momentum balance to know the velocity of the flow. In this way, we calculate this velocity using mixing lines of Prandtl theory, Kolmogorov theory, and many theories that were adapted to a stirred vessel geometry. And we're able to calculate gas drop, gas holdup, solid dissolution, solid distribution, drop size, mass transfer coefficient, heat transfer coefficient, all the parameters that we know chemists, process engineering are looking for in order to be sure that the performance of the process in the equipment will be the required in order to succeed to transfer the process in a good way. Companies working with us in different fields, in different areas. You can see pharmaceuticals or manufacture of equipment, chemistry, specialty chemistry, polymers. Every place you have a stirred vessel, you can use the software in order to solve and to progress. And of course, we have users that Dr. Victor Atiemo Beng. I hope he's here and hearing us, and he advised how to use the software. He is now retired from Dow Chemical. He was there a mixing expert in the company, and used the software in order to understand the best way to generate the knowledge for the company. We have customers in all over the world that using the software and renewing the software every year. The use is mainly in the technology transfer, in the scale up, and is of course in the design, in the optimization, in the troubleshooting. And companies that you can see are renewing the software every year. We are providing normally licenses per year. Of course, for this release, for our customers, of course, you will receive a very good complement in the use of the software. And for the new users, of course, we're very happy to fix with you a meeting for your company and share through one of your cases the use of the software in this direction. So, what is the motivation? And the motivation is very simple. I'm sure that you are trying to solve these questions when you are working at this stage. And the summary of these questions is what is the connection between the equipment and the process? This is, and this step, the main important question we need to answer, and the company is waiting for it. Because we succeeded in the lab or in all the equipment, or we decide that we need to progress to other steps, even if it is not perfect, the process. And we need to be able to answer to the company, okay, this equipment and this facility will be good. This other equipment, we don't know. With this equipment, we have doubts. We have people completely know. This is my role. This is your role. This is the role that you are playing in the company at this stage. And the environment around these activities are very clear. You have a very high management focus at this stage because it is the future of the company. You have some commitment in the market. So everyone will ask you, okay, how is going on with the technology transfer, with the scale up? You have a very good management focus. But on the other hand, the same people that are focused, they are feeling very relaxed, yes? Because they feel, okay, we succeed in the older equipment or in the lab. We have the same raw materials. We didn't change the raw material quality. And we have the same process. We are not changing the process. So what is the big deal? It will be okay. We will succeed. But people like you that are working in this field some years, you know well that it is a very precious stage because you are really going to different equipment and you know that there's a change here and you need to answer. And sometimes it's not so good and the price is very high and the risk is a problem because you are increasing maybe the quantity of material you are using, so the size, you are investing more money, and you have some commitment to the market. Maybe you are producing in other place, but you continue to be able to supply the material to the market. So it's very pressure. And you know that it's not so straightforward. And the reason that we want to tell you that if it is the same material you are using and the same recipe you are using, then it's something that you are really changing. You are changing the environment that you are providing to your process. Your process is running in a flow. When you are running your process in a different mixing, the meaning of this, of different size, or different geometry, the meaning of this, you are providing different conditions to your process. And if it is different conditions, the meaning of this is that maybe it will be not a condition that you need for your process. So our main goal is to succeed at the first time and to understand where we need to ask the relevant question in order to evaluate if we are under the conditions that will be good for us. And it is the only change that you are doing is mixing. As a consequence of this, maybe you will need to ask about the process, about the temperatures, about new impurities, and so on. But the source of all the activities around is coming from this unit operation. So with the software, of course, we're able to calculate from the R&D. If you are doing in this way, you will be able to anticipate some knowledge with the design and the production equipment, and you will be able to justify by using quality by design and define what will be the critical parameter and what will be the control strategy in the company. But what is the good mixing? And this question is critical because the answer in this question should be very well evaluated. Good mixing is the conditions we need to provide to the production to generate good results. And not always is homogeneity, high velocity, high shear rate, because our goal is to generate materials in the industry. And the tool that we use is mixing. So I need to provide conditions to my process through the mixing. So tell me what is the process, and we'll tell you what is the mixing. The example that can illustrate it, you can see it here. Some company have some problems with in equipment that they design and start to manufacture a process that was the same process in 3 different equipments, and they had some problems in the new design. They wanted to do some fine-tuning in the new design to succeed. The process was solid liquid, so chemical porous, but solid liquid, okay? And they found that the properties of the flow were much higher. The meaning of this, over than they expected, and they generate some problems. You can see here, it was known that oxygen hydrolysis destroyed the sugar. In this case, it was the material when they had contact with the oxygen. When they evaluate, they try to do trial and error. It was not succeeded. They use the software, and you can see what happened here. Due to the design of the old impeller, all the bits were found in the lower part of the reactor. But when they design, they assume that they need homogeneity, because good mixing, good process will be homogeneity. But good process is not good mixing. Good process is my material in good way. Good mixing might be homogeneity, but the tool is the mixing, and the goal is the process. We need to provide. So they understand with VisiMix that when they increase the homogeneity, they generate the impurity, or they destroy the sugar, and they get no good results. So the solid should be in the bottom of the tank, moving, but in the bottom of the tank. And the conclusions were that in this case, we understood what the combination of the company knowledge of the process with mixing simulation is more than must. And the reason was that the knowledge about the impurity was not so clear. And the second point, the launch was delayed by 6 months, and they lost about 1.2 million euro. And this is the order of magnitude. We're working at these big units, you're missing money, and the cost is very high. So we have to take care. You can see the new configuration, the older configuration. Here solids were mainly in the bottom. Here the solids were well distributed, and what was the source for the problem. So based on it, we want to propose to you, according to an experience that I collect when I was pilot manager during many years in the fine chemistry industry, in the API, in the pharmaceutical industry, is to try to decrease the number of required batches to validation process in the production step. And the idea was to change a little the way to think and try to anticipate what will happen in the production step, try to set up in pilot in some way that when we run the process in the pilot step or in the lab step will be the same conditions we will provide in the production step. So we did, and the illustration you can see here. You can see some illustration about very big voltage, solids in the bottom, and how when I'm changing the mixing in the tank by including some buffers, you will see how the vortex is disappearing, and the solids will start to move and be more homogeneous. I don't know if it would be good for the process or no, but I know that it's different and quite different. So I'm able to generate a wide range of work in the lab, and with the help of the software, we'll be able to calculate those parameters, will be the range of work that is possible, and see how it will be possible to meet the condition that we'll find in the production step. So the idea is to understand the process, to calculate with the software what happened in the production step, to go to the paint scale and set up the equipment in the way that will be similar, and after that to find design and the final design, operation and design if it's required, and have a model. This is a very important point. I will have a model that answer me the relevant question I have. And on this idea, it was developed the software. So you have here all the steps. We have other presentations about it, and some publication I released during this year in different journals. So you can follow up it and understand every step what we intend to do. And of course, we have other publications that show the studies we did in different unit operations, how we keep fix some of the parameters that control the process, and how to select the equipment in the production according to what we know. In this way, you are closing all the way. And of course, it gives you a capability to reduce dramatically the expenses. So we reduce, in our case, the money the number of lots that we lost during the transfer technology from 100 to below 5. And it was very succeeding, of course. From this to now, complete software, very good equipment is available. So you will be able to, in a short way, to understand if your production equipment is really good, and you answer in this way the question that you are looking for and the company is looking for you. So this is the VisiMix scaling up options. We have two main options that we're thinking about. Some of them will release now, some of them will release until the end of the year. But the main idea is the follow. The first is to have some reference in the lab, in the pilot, and by one clicking button, we will keep fix the geometry similarity and the dynamic similarity, and will provide to you directly what will be all the parameters designed for the big equipment that will keep fix the process, that will be the crystallization and the reaction, or the emulsification, or the pickup from the bottom, or the homogeneity, whatever you are looking for, by one click button, you will be able to do it. The second option is to select the unit operation, and the software will tell you which of the parameters is important to keep fixed. And in the next part of the year, we will be able to complete the technology transfer, but compare in one button by selecting the process, compare and generate tables that compare between the equipment you use and the equipment is available according to the unit operation you want to compare and to succeed to transfer. So this is the main point. So the purpose is a new function that will give you new processes to provide sustained definition of both equipment characteristics and process after scale-up procedures, or scale down. If you know your process in the production, like the methodology, you will go to the pilot and you will ask which small equipment will be able to provide to me the same energy of dissipation, solid distribution, reaction rate, crystallization, whatever you're looking for. In one click, I will show to you in a few seconds. So the first part, the explanation is here you have some a prototype that can be the production or the lab, and you will be able to do some work about the kinetics and calculate the rotation speed, the power, energy of dissipation, whatever you want. The second is by using K parameters for the unit operation, the software will define what will be the parameter required to keep fixed, and after that to provide to you the scale-up equipment ready to use. We have some question I will answer after we finish the idea. So, what is the scaling function? The scaling function, so the first part that we are keeping fixed, the geometry, is in this way. In your normal VisiMix project, of course, you need to do new in order to start to work and generate a model. Once you have a model, you can go to project and you can see here project scale up. And the second that it's not now ready, it will be ready until the end of the year, will be technical technology transfer. When you click scale up down, what will happen in this way or in this way, you will see now the new button here, and another new button will be at the end of the year. When you will click there, what will happen? The software will provide to you some way that define what will be the factor. So give me the factor. You go scale down by from 2000 liter to 2 liter or from 2 liter to 2000 liter. And this factor we will use. You will not see the factor. You need only to give me what is the reactor volume or reactor diameter. And with this, we will be able to provide to you the complete design by keeping fixed the geometry similarity. So if you have a tank like this, when you feed all the data of your tank, you click scaling up and you see this is your prototype. It can be 6 cubic meter or 1 liter. When you have the target that will be the volume of the tank or the diameter of the tank, and you click estimate or calculate, the software will calculate according to your selecting parameter if you know it, or if you don't know it, the software will ask you, in this case was the same parameter, okay? The software will ask you, okay, select the unit operation. Let's say you select mass transfer rate, gas liquid here, and the software will tell you, okay, I will do according to the micro mixing time or something like this. And when you click here, you will have here the explanation of why this unit operation is required to fix the first mixing parameters that we advise to you. Okay, all of this in one single button. And it is really what is changing. Okay, not the chemistry, not the recipe. This is the change. Now, when you have this change, you can start to evaluate, okay, it's not possible. What will happen if I have smaller particles? I have no enough heat transfer. I have no enough mass transfer. This is a consequence of the tool. You will have now the questions in your mouth ready to ask to the company in order to provide a professional answer. This is the point. Okay? So only to remind you that we have in our software, this menu in the help that connect you between the case scaling up parameter, where it's located in which menu for which unit operation. Okay, and based on this list and to understand the explanation we wrote now, I will show to you, we will be able to provide to you the scaling up that you are looking for. Okay, so you can do scaling up for different parameters. You can do normal scale up and after that technical transfer technology. All of this ready to use to the parameter and to the unit operation that we know is the only unit operation that is changing. Okay, so I remind you it is written here. You can, of course, read in your notes that we share with you. And the best way to work is the following. In the first step, understand what is the basic mixing parameters. It comes to the mixing time, to the power per volume, power, circulation flow. The second step is to define the mixing parameters, okay? Mixing times in different levels. And the third step is to evaluate the structure of the specific unit operation, that is crystallization, reactions, and so on. We have in the next steps for different unit operations, what are the parameters? So for instance, for basic mixing, those are the parameters. The second step, those are the parameters for the mixing times and the local mixing. And here the step 3, how is changing the concentration in some reactors, or if we are looking for solid liquid, this is the third stage. or for suspension, the third stage, or for a collision, the third stage. As you can see, we have here for many of them. In this case, it's crystallization. This is the second part, of course. This is the technology transfer based on the scale. So what you can see here the examples, and we'll provide to you all of this. It is in the presentation only to give you an idea. For a unit operation, we separate every table to put you in this presentation that is informative, clear for you. Okay? So this is the summary of our complete duty. Our first stage is to provide to you the button for the scale up and the relevant parameters you need, because you need to answer to the company. The second stage that will be at the end of the year will be the technology transfer, how to compare this good scale up to the equipment that you are really have in your hands, and to see if you are close or very far from them. And of course, based on it, bold the answer, and everyone will understand you and will tell you give you the answer, because it's critical. The management know that this stage is critical. They know maybe that it's more simpler that you know that it's a little more complicated, but they know that it's important, so they will provide you all that you require it for it. Okay? You need to show that you are professional, and this is the way to do professional, to put in the table what is really the change. Okay, as you remember well, we have some examples only to remind to you in 5 minutes before I open the software. Exclusive points that examples that are very good to remember and to refresh. We have homogeneous reaction. This homogeneous, that it is salts that are completely clear and very no color system, transparent. And when we feed HCl, we have iodine that in no good spray of HCl, we have iodine that it is no color. And when we don't have iodine, when we have very good spray of HCl, we have no color, it's transparent. And I've showed to you in some opportunities. Oh, sorry. It is possible to show how, I have not the video now, it's possible to show how the color is completely different when we feed the material, when we have very good concentration. So we feed the material here, or we feed material here at low velocity, you see completely different colors. You are invited, we have here in our website. The second point is the crystallization. This is the parameter that now will be available for you in the new tool. So you will select one of them, and the software will completely give you the results. We have here explanation for every one of them, and of course you will have in the software. And the curious example that we have there is when we transfer, we have some problems during the year that the particle size changed so dramatically from 195 micron to 325 micron. And the main difference here was some maloperation that generated the mesh of the impeller that reduced the diameter of the impeller. And when you reduce the diameter of the impeller, you have less energy provided in the volume, so the eddy size will be bigger, and it will generate big particle size. So we know it, and we calculate the energy of dissipation, and in this case we have smaller particle size. We have is here smaller particle size, here bigger particle size. The other example that we want to remind you is a company contact us. They have 1,000 liter equipment and they wanted to go to 10,000 liter equipment, but the problem was that they had only 4 hours in 1,000 liter, and they went to production. They go to 4 days and was completely disaster. They contact us and they show us that in the lab, in the pilot, they feed from Sparger, and in the production, they feed in a deep tube here. We show them immediately that if you are feeding here, your gas is going up, and when you are feeding here, the gas is inside. They told us that they have no way to install Sparger in the new equipment. So what we advise them after some discussion is to change the position, but change the probe of the gas deep pipe hole in the cover of the tank to other place that it is inclinated, And once you are feeding close to the impeller, you have a very good suction, and you are breaking up the drops, the bubbles to small one. We don't reach 4 hours because we lose this part of the tank, but we reach 14 hours. That was very good. And the last example is a combination of technologies that normally are not in the same industry. So you have a reaction that generates impurity L and the main product D. And when they feed the material chloride to the amine, they generate a different levels of mixing, different impurities that you can see here. But someone in the lab understand that when you are increasing the RPM, you are doing better results. So they use homogenizers or rotor-stator, and they generate zero impurity by 15,000 RPM. But when we calculate the turbulent shear rate, that was the main important parameter, we see that it's impossible in comparison to the production to generate the same turbulent shear rate. So what we did is we advised to install something here close to the impeller, and of course, when the material will enter to the rotor stator, will generate better results. So only to remind to you different kinds of histories. And every one of them is millions of dollars. But the point, the more important point, from your professional point of view, is that you are answering according to what is really changing in a professional way with models that were validated and used for more than 20 years in many companies all over the world and prove themselves everywhere and every time. So this is the complete way to think. From this study, I apply in a company, and now I finalized the PhD. So I hope the publications we did in this field will help the industry to generate fast result for every material. And right now, of course, for the coronavirus, if we help in some way to accelerate the way to work, we're very happy. We have different kinds of products. I cannot enter inside them, but you can see during the time we increase our portfolio to more and more products. So if at the beginning we talk about regime and high viscosity or low viscosity, during the times we have different kinds of installations, different impellers, off-center, bubble columns that mixing with no impeller or high shear rate. We have some connection to how to connect to the VisiMix results, and of course, pipeline and 3 dimensions try to help you to elaborate the result and to present it to the company. So I will not cover this part. This you have in your handouts, and you can select and of course ask any question you have. Okay. I will answer the questions in a few minutes. They are not so problematic one. Okay, so all of this part we will skip every explanation about every product. Only we invite to you, please come to our website, visit us, and you will get all the explanations, presentations, mathematical models, testimonials from companies. And by then, our purpose always is to give you a capability to understand better your process in a fast way, and to emphasize that VisiMix is a complete model that use tools in order to provide to you a capability to integrate a phenomenon that happens anywhere in your tank with your process. Okay, so based on it, and thank you very much for this part, I will open the new application. So it's the same way to work, okay? So we have turbulent. Let's say I will have a new project, okay? And the name will be scaled up, scaled down. And what I have here is a tank. I have to select a tank. I will select, for instance, this tank. And the main important parameter will be, of course, the diameter of the tank, the volume, nominal volume of the tank, and the volume I have inside. Now, when you click OK, let's say you have buffer like this. You have 4 buffers, 160 millimeter. Big number will give me the maximum one. distance from the bottom, distance from the wall, and of course a normal angle between the R-axis and the buffer that is 0 degrees. I can select, for instance, that I have a pinch pedal, okay? And in my pinch pedal that I have, the diameter will be, for instance, 800. I have 4 blades, 45 degree. The weight of the blades, let's say, will be 120. The distance from the bottom 450. The RPM, then maximum I can use 120, and my motor 7,500. I have here some density. I use like now water only to facilitate it, and viscosity. And I will add, for instance, some solids, okay? And it will be 1001. The concentration of the solid will be 10%, the density 1,500, and the particle size will be from 100 micron to 200 micron. Okay? Okay, this is my system ready to use. This is my system. I want to go down. How to do? Scale up or down. Open, ready. What you want to do? For instance, you want now to use in a cube meter 0.0 2 liters, okay? Immediately calculate the diameter, and I can select at the beginning of the way that I want to do scale up based on energy of dissipation, you see, or micromixing times, or impeller radius number. As you see how immediately changing the results, okay? Or other way to do is to come or enter a target of velocity. Let's say I want 700, the maximum that I can do. Okay? I can estimate again. Or other way to do is to come to one of the unit operations. Let's say I want a suspension. You see here you have the parameter that we selected, and here the explanation why at this stage this parameter is the main important one. The explanation is scientific one. We need to take care about the Plechet number to maintain the solids moving according to the geometry similarity and dynamic similarity. And like this, I can select every one of them. And for every one of them, for every one of them, I will get some explanation. Okay. Okay. So let's say I am happy with it. I get immediately what is the velocity I have to apply in the lab. You see, this was the evolution, it was the lab. But when I click OK, now I will click here, the name will be lab. Okay, lab. And when you click save, now you have two equipments ready to use. In the lab equipment, I have some solid distribution. Okay, that the solid distribution is the following. You have here the bottom of the tank and the top of the tank. You have here the local concentration. So if you take sample, for instance, from the bottom of the tank, and you will measure what is the real concentration there, and you will compare with the average concentration, and in our case was 100 picogram per cubic meter of solid. Now you will measure about 108 kilogram per cubic meter. Okay, so the relative concentration is the local concentration divided by the average concentration, so it's 1.08 or 1.1. And when you are going from the bottom of the tank to the top of the tank, you see how the concentration of the solids is decreasing. You have more material in the bottom and in the top, and it is clear because my material is high. Now, if I tile and I come to my original equipment that was slow scaling down, I can calculate the actual distribution, and you see that it is a little different. It is not the same. Yes, because I ask in my options, I ask the picking the material that will take will moving. So the minimum velocity to generate moving of the solids, no the position of the precipitation of the solid in the bottom of the tank that are not moving, just solid suspension. Okay, so for this it gives me the velocity, and the particle size is different. If I ask from here again, okay, scale down to suspension, okay, and estimate for 2 liter, an estimate, you see now, is 1,350. When I click there, and I have lab number 2, now this is my equipment, and I will calculate the actual distribution. Now will be exactly the same. You see, this is exactly the same that we have here. This is my actual model, and it is my scale-up calculations. Now from here, now you are in the lab. This is the prototype you need. If you have a slight deviation in the lab, it is not a problem. Use what you know. Use the clone, okay, and change here a little the diameter of the velocity, whatever you want, okay. And let's say that you are 1,000, and you will be able to tell everyone, you know, now my deviation in the particle size will be instead 4%, 6%, so no big deal, it's close to the same, go ahead. This is the tool, ready to use. You want to generate reports that you remember well. We have completely reports about solid liquid mixing, okay, that give you a capability to give a name, okay, and with the use of Excel, with the help of this Excel, build a report, okay, that contains, let's say, the volume, the RPM, and the non-uniformity. Okay, this is for my 1.5 liter, and if I do exactly the same for my scale down, exactly the same report, I will, of course, get the results for it. Directly come to Excel and add my original data. Okay. Now it's different because, if you remember, I changed the velocity node to 1,600. What the software provides me, I changed to the maximum possible. Okay. So like this, we can progress. I have some minutes to answer you some questions. So I will start to read the question that coming from the people. First questions. Can we use this software for rubber compounding processes? Yes. We have many customers about it. You are invited to contact us, and we will provide to you a presentation and ask you what will be the best configuration for you. Seems interesting. Now people can play better with data. Thank you very much, Mr. Malvilla. I'm happy to see you here. Do you plan to add the ability to do sensibility between a range of parameters? Yes, it will be in future, but in the next step, that it is until the end of the year, technology transfer package or product, we will be able, with a smart way, when you feed your data, you will feed the maximum to know what will be the range of work in the bottom that I showed to you. One bottom, this bottom, that will be available until the end of the year. Thank you very much, Cliff. Why is flow properties shows viscosity not incorporated? Okay. Normally, when we are working in some range of work, we are able to connect with the power law or Cornu model, And in the range of work, normally it's working well, but if not, we need to divide the calculations into 3 steps and generate the results. Next question. Yes, we have answers about enzyme and biotechnology and growing of microorganisms in fermentations. All of this we have. About the enzyme, we know well how to manage it, and we know how to advise people how to use, because by then you can, according to the progress of the reaction, you can manage the importance of the mass transfer in the process with a very simple way. The scaling up software is ready to use. Okay, it's only contact, and we're happy to provide to you. If it is possible to get a copy of the video, of course, we will upload it after the meeting today. Does this software can also support in simulation of other unit operations like static mixer pipe reactor or skinning disk reactor? Right now, no, it's in the plan of the company. We hope we will release it as soon as it's possible according to the activities we have inside the company. If you are in specific application, we can start to think about it, and maybe because you will push us, we will release it faster. How we can utilize this software in process intensification? Of course, this is the main point. Once you know what is the influence of the hydrodynamic in the system, the influence of the mixing in the process, this is open all the capabilities to think what will be the best configuration for you, and even to extrapolate to the mixing intensity when you don't have agitator bubble columns, or when you are using in the pipe. Okay, of course, it is part of the knowledge. Hello, 5-liter bioreactor shaft placed diagonally. Can we? Yes, of course. We have a capability to have off-center for this kind of application. It's simple to do. You will need VisiMix off-center and VisiMix turbulent in order to have your agitator inclinated. And when you have 50 liter, it's enough volume in order to know well what will be a good approach to the big equipment. We have companies that go up from 1 liter to 30,000 liters. Okay. Bioreactor explain is okay. Will the facility scale up and down available for users who have VisiMix turbulent model? Yes, please contact us, and we will find a way according to the configuration to provide to you. Yes, for the customers, you know, you are the users, and you will have an advance of it, and you will be able to start to work. It's possible to simulate reactive multi-phase mixing. Yes, you need how to manage it. Okay, when you have multi-phase reactions, you have to separate between all the way of the material to come between the phases, that it is mass transfer, and after that to understand if your process is controlled by the mass transfer or by the reaction rate. And it is simple to do, and with the software we will be able to provide to you some idea about what is the maximum capability of mass transfer possible in your equipment. And when you will see your result, you will see immediately if you need to take care about it, or in your case, it will be easier to decide. Is this available in DI and laminar also? Right now, no, it's only turbulent. We hope we will progress in the other unit operations. If it is possible to calculate mixing parameters from photo-bioreactors, yes, mixing is not a function of light or pressure. So yes, no problem. We need to understand better what is the use. If I want to keep flow profiles, what option I should use in scale-up? The option that is available there is to have the impeller velocity or the energy of dissipation. You know, the mixing profile is depending what you're looking for. You remember we are mixing multidimensional phenomena. You have fluid elements moving in different zones, and you need to provide the direction for it. So it's depending what is the influence in your process. It's a local mixing, the interaction between the fluid elements, or the integration of it, the hydrodynamics. So for this, we have or flow rate, or micro mixing time, or Reynolds. Okay, it's depending on the process. Can you show the result in imperial units as well as SI? We show the results in SI. We can feed the data in imperial units. Can you manage a large change in viscosity during the course of the reaction? Yes. The point is that maybe when you are going to high viscosity, you will enter to the laminar regime, and for this you need to go to VisiMix laminar product. Okay? I may have missed the answer, but when will scale up down function be released? Is released. Please, Eric, I'm very happy to see you here. Contact us. You are a customer, and you will have to only require have some requests, and our sales people will contact you in order to organize how to progress. Okay, so it is ready, only used. If you performing a pilot case resuspension with the aim to replicate particle size at full scale, how efficient are the suggested pilot scale parameter and replication the particle size? One of the main use of the software is the crystallization, okay, in many companies. So take care, and for this we are very happy. We are very happy to provide to you a special presentation. Take care that crystallization is playing in all the fields. So you have fluid elements interacting. So the local mixing will be important to the nucleation growing. The distribution of the solid will be important for the purification, and both of them will be important for the morphology and attrition. So crystallization is very useful, but you need to combine different parameters, not only one. The main important one at the beginning of the way, of course, is the mixing energy of dissipation local, and for this you see we had it in the scale up. How does the system respond to a volume change during the reaction? Yes. If you are working in semi-batch, we assume that you are feeding about less than 10% of the media. When you have more than this, we advise, of course, to change the volume by do clone and change the volume and calculate again in order to know what is the change in the mixing parameters. If you are doing it in some reaction that is exothermic reaction, it is included. You can feed 40% of the volume, and the software will calculate what would be the temperature and function of the time when the volume is changing. Okay? Can various impellers can be added and simulate only in VisiMix turbulent? We have different impellers, not only turbulent. We have turbulent and different impellers, and in the different impeller software, we're able to install 5 different impellers in the same shaft. So stage 1, stage 2, up to 5 stages, and calculate the main hydrodynamic parameters. And with the help of the scale-up, you will be able to know which parameter is important to keep fixed during the activity scale-down, scale-up. Can you elaborate a bit of radial and axial uniformity? Yes, we talk about it. I will explain a few minutes now. The main idea is the following. You have axial distribution. This is the bottom of the tank, and it is the top of the tank, and it is the relative concentration. So if I take a sample from my tank in the bottom of the tank, sample from the bottom of the tank, and I measure what is the solid distribution, I will get a number that will be 101 kilogram per cubic meter. 103 kilogram per cubic meter. When I divide it by 100 kilogram per cubic meter, that it is the quantity of material I have fit in my tank, I have the relative concentration. If I calculate now the same it will be the radial distribution. Now, this axis you will see is the center of the tank, and it is the wall of the tank. And what happened here is that it's pretty homogeneous because it's 0.002. But the meaning of this, you have less concentration in the center of the tank than in the wall of the tank. Okay, the deviation in this case is very low; it's only 0.3%. Okay, from the average. But it is informative and sometimes it's very important to show. Okay. Yes, we succeeded to answer all the questions. Now is we pass the time. So thank you very much for attend. It's really important to take in consideration the unit operation. We elaborate this product for you after many years of thinking what will be the best way, and we are on the middle of the way. This product is ready to use, and the technology transfer that it is a capability to generate a smart comparison between the stages and the information you have in your hands to decide in a good way and to answer the company about the main question that is the question that you need to answer at this stage. We expected to provide it to you in a good way, in the bottom, into the software with all the knowledge that we are able to provide in a good way. So thank you very much for attending. Happy to see you here, and we're happy to see you again in your specific application. Contact us. We'll of course contact you in order to interest you in your company and progress with these tools. Thank you very much.